Hello, everyone. So today's lecture topic is a knowledge graph. Let me briefly introduce about what the knowledge graph is. So this is a visualization of a knowledge graph from the Google Knowledge Graph team blog. So the search engine in shopping mall and many commercial system is starting to exploit the knowledge graph concept. So it is about the relationships between places and events and experience in homes and tags and so on. So it is about everything you know. For example, when it comes to new football game, so we are able to see the result. So when you are familiar with the Google search engines, the card system, so they are based on the knowledge graph because it shows the result of the recent football game. You understand who scored the goal in the game and their statistics in their hometowns and many other information. So the fact around the football game and player is described in this kind of knowledge graph. Similarly, when you open the Google map, you search the restaurants and some locations and neighborhood, their information around their geocode and their some categorical informations are described in the knowledge graph as well. They all relate to each other. Some applications show the partial information. Sometimes it doesn't look like a graph, but the underlying technology uses the knowledge graph. Let me give you some their formalization. So knowledge in graph, node, and edge are presented like this. So each entity, sometimes we call entity for node in the knowledge graph, it has specific types for the entity. For example, the entity could be school, maybe university. For example, in our school, we understand our university is private school, and the category is, I don't know, university. So this is a type of schools, right? It has two types. We assume that. So it could be categories like A1 or A2, and it may have multiple the entity types. In each individual nodes are associated with the edge. It has specific relationships. The nodes are labeled up with their types. I explained this. So this is the formalization of the knowledge graph. Maybe you may see more enriched knowledge graph in your paper. Sometimes it may have some weight for the relationship. Maybe it is normalized between 0 to 1. This represents strength of the relationship or significance of the relationships. And this relationship may have some the type information. Many different variations, but basically they are formalized on top of this sort of the notations. This is example, very famous example, the bibliographic network. So This is open to the public. Many researchers use these knowledge graphs for their experiments. So usually the notes represent the paper, title, author, conference, and year. So this is publisher IEEE ICDE's conference name. The ICD has the publisher information. They are associated with this relation type, and each papers are cited. And we would know the author of the paper using this H. These are the authors about this paper. So we can represent more information compared to the homogeneous graph. So far we have dealt with homogeneous graph. It doesn't have the type of entity, it doesn't have some name of the relationship. We assumed that they all people, or they all paper, they all single edges, I mean a single type of edge, and so on. But by using this notation, we can represent more complex information. This is another example about the knowledge graph. So it is about our common sense. When you wake up in the morning, you feel still sleepy, so you can expect another sub event after this is a yawn, and maybe you can check email, right? As soon as you wake up in the morning, check email, drink coffee, and wash your body. And this is a generalization about this activity. And to wake up, we use alarm clock. And go to bed early is the motivation, right? To wake up in the morning, we need to get to the bed early. So prerequisite of this concept is so eat breakfast. So eat breakfast. So we need to wake up in the morning, right? To eat breakfast. And the effect of the eat breakfast is and to be full stomach, and kitchen table, in-house, and chair, they're all related, and these are about our common sense. The difference between this concept net and this sort of graph is, so their information is mostly about the factual information. Yeah, they all related the factual and pretty inarguable information. But in this case, it is more about situational information, and the relationship wise, it looks more useful to understand the given context or situation. So it has used for the reasoning about the future action, because we understand their motivation in the uses about some object, and it has used for the reasoning the situation and in predicting the next event. But still, we need to move forward. But these were the main source of the information to train. So you can visit the concept on the webpage. And so these are widgets. When I search money, we can see that they are related to the bank, wallet, and profit and dollar information. And the things that require money. So this is the relationship name, and you need money to buy search and product and going to film, right? The location, the money as bank wallet, they all looks very useful, right? It is about the motivation and return to work, serve customer is motivated by money. Type of money, and it still include factual information and many things else. I would like to say, so these paper, as far as I remember, this is constant version 2 or 3. I couldn't remember exactly. So now their version is 2, or they have 2 or 3 more recent updates, and they include many factual information like these the Wikipedia based factual information are now part of the concept net, so they are not solely about the concept, the common sense. It is more like a encyclopedia about every concept. So maybe that's why the name, as the name represents, they are about concept rather than common sense. But anyway, it was designed to represent common sense, but not anymore. But still, many people use. So anyway, the many knowledge bases which are publicly available. For the factual knowledge, you find us, and for the common sense, many variation from concept net, common and atomic and transformist. So these are another project and many variations. So OMSIS is the initial point to develop the concept net. Anyway, you don't need to remember everything. They all a very long history, so they all based on the Wikipedia, and many the knowledge triple extraction techniques are involved in this. And people participate to construct manually, and people use the artificial intelligence in text mining technique. I mean, they use the text mining to extract the knowledge triple. All right. So now you understand what the graph embedding means, right? We reduce the dimensionality for every node. Similarly, from this knowledge graph, you try to reduce the dimensionality and apply for a specific downstream task. Similarly, we can predict link, right? It is still sparse for the knowledge graph. We try to find the relationship between the two rings when they are related, and we can put the entity type when it is not available. It could be seen as node classification. For the triple classification, it is like assigning the relationship. So by having the node A and node B, so this is known. So we try to understand their relationship. For example, here, when we can give kitchen table for the A and chair for the B, we can classify their edge. So the answer is part of, right? But we try to classify the relationship name. We need to assume that all the possible relationship names are known in advance. It is predetermined, and we just classify the one of them. So now we are interested in the QA with the massive collections of full text documents, and simply returning relevant documents is of limited use. Rather, we often want answers to our questions. So QA is one of a very important tasks, and this is one of the very important applications for the knowledge graph. As you know, we had many progress on the Q&A, right? I think that most of you are familiar with the squad. So we assume that the passes are given and 2 questions, you try to get the answer, right? To get this answer, we need to understand the keywords which are related to the questions, and we try to answer and considering the passage contents, right? So these are beyond the human beings' performance right now. So we try to getting the more difficult and difficult, and we keep developing different version of Squirt and still making the new one and with another name, right? For example, we try to solve the numerical computation, right? You know, the Elisa had initially had $20 and borrowed the money from Elisa, and Christine got $20 from the Elisa, and we expect some computations around those people, and we try to get the answer, something like that. There are many variations. We're still doing good in the Q&A. I mean, for the very easy task. So we have many difficult Q&A tasks. So for example, we have common sense Q&A. So it's difficult to have the answer, and let me give a different slide when I upload this video. So we try to answer without seeing all the possible choices. So where do adults use glue sticks? So where do adults use glue sticks? So adult doesn't go to elementary school, middle school. They go to the office. I mean, by common sense, right? And we use the glue stick in office, right? This is from our common sense, not classroom and not the other place. It is likely to be office by common sense. So that is the point. That's why it is difficult. So we are assuming in very specific situations, and by considering this situation and information, and we need to reason about this, the missing information, so which is not given to context. I mean, that's why common sense QA is difficult. So when you see the relations at location, so to solve this question, where would I not want a fox? So A is hen house, B is England, C is mountain. What do you expect for the answer? Where would I not want a fox? Are you able to see the answer? The answer is hen house, right? Otherwise, the fox will eat everything, hunt every hen, right? Let's see the second case. What is the hopeful result of going to see a play? It is saying hopeful. So it's likely to be the being entertained, right? The answer is all the answers are in the A. So yes, I'm sorry. So read everything and you see how difficult it is. To human being, it is very straightforward, but difficult to solve question using the existing language model in the typical QA question. So that's why people try to leverage knowledge graph to solve these questions.